Simultaneous equations. On occasions, you will come across two or more unknown quantities and two or more equations relating them. These are called simultaneous equations, and when asked to solve them, you must find values of the unknowns which satisfy all the given equations at the same time. Solving a pair of simultaneous equations. There are many ways of solving simultaneous equations. Perhaps the simplest way is elimination. This is a process which involves removing or eliminating one of the unknowns to leave a single equation which involves the other unknown. The method is best illustrated by the following example. Example: failure of a plastic pipe can be expressed by Miner's rule as displayed, where lowercase t subscript f is time to failure in seconds, uppercase T is temperature in kelvins, sigma is stress in megapascals, and in the expression A, B and C are constants. We know the value for B and it is -500. We are required to find the values for the other two constants, A and C. The following information is known for a given pipe. When a pipe is subjected to operational condition 1, where stress applied is 40 megapascals, operating temperature is 50 degrees Celsius, the lifetime to failure is 7,598 seconds. And when a given pipe is subjected to an operational condition 2, where stress applied is 30 megapascals, operating temperature is 30 degrees Celsius, the lifetime to failure is 80,184 seconds. Using these values from the two operational conditions and the Miner's rule displayed, we can find constants A and C by solving simultaneous equations. Let's do this. First step is to make sure the information we've been given is in the correct units. You may have noticed that the temperature provided is in degrees Celsius. We need to convert it to kelvins. This is done by adding 273 to the temperature in Celsius. And we get 323 Kelvin for condition 1 and 303 Kelvin for operational condition 2. Now that we've confirmed that all the units are correct for the Miner's rule, we can insert these values into the expression, and that will result in two equations with two unknowns. The Miner's rule expression is displayed. Let's consider the known parameters for operational condition 1 and insert these into the expression. We get log of 7,598, which is equal to A plus -500 divided by 323 multiplied by log of 40 plus C divided by 323. We'll call this equation 1. This can be written as 3.88, which is equal to A minus 2.48 plus C divided by 323. We can combine some terms, giving us 6.36, which is equal to A plus C divided by 323. And now, take the known parameters for operation condition 2 and insert these into the expression. We get log of 80,184 is equal to A plus -500 divided by 303 multiplied by log of 30 plus C divided by 303. We'll call this equation 2. This can be written as 4.90 is equal to A minus 2.44 plus C divided by 303. We can combine some terms. We get 7.34 is equal to A plus C divided by 303. These are exactly the same as equations 1 and 2 from before. Now we can subtract one equation from the other. For example, equation 2 take away equation 1. This gives us 7.34 take away 6.36, which is equal to A take away A plus C divided by 303 take away C divided by 323. Let's do the takeaway operation. So this gives us 0.98 is equal to C multiplied by bracket open 1 divided by 303 take away 1 divided by 323 bracket closed. And now we can calculate the value for C, which is 4795.58. Consider equation 1. We can insert the value of C into equation 1. We get the value for A, which is minus 8.49 or negative 8.49. We've done it. We have now found the two unknown constants A and C. A is equal to negative 8.49 and C is equal to 4795.58. You can check your answer by putting these values back into the equations.